All right. So combustion. So first off, what is combustion? Okay. Combustion means something plus O2. If you have combustion, it means you're reacting something with oxygen. But what we're specifically talking about in these problems is hydrocarbon combustion. So that means something with C and H plus O2, and it always makes CO2 plus H2O. Hydrocarbon. Hydrocarbon means it contains hydrogen and carbon. So in this particular problem, which is 93, you are told you have fructose, a compound that contains carbon, hydrogen, and oxygen. So it's carbon, it's hydrogen, it's oxygen, but you don't know how much yet. But you know when it burns, you make carbon dioxide and water. So you've got 2.20 grams of carbon dioxide, and that's all carbon from fructose. So if you figure out how much carbon is in that CO2, you know how much carbon was in your fructose. You know you have 0.900 grams of hydrogen, and that's all the hydrogen from fructose. So if you have 2.20 grams of CO2 and you want to know how many grams of just carbon are in that, what are you putting on the top? Carbon. And what are you putting on the bottom? Not oxygen, carbon dioxide. Because you want grams of carbon dioxide to cancel, and you want grams of carbon to be left. So, grams of carbon and grams of carbon dioxide, look up their molar masses. The molar mass of carbon, you've done this one a lot. Do you know this one yet? 12.01. Okay, carbon dioxide is 44.01. One carbon, two oxygens. Each oxygen is 16. Okay, so when you do the math, that's what you get. So now we take our 0.900 grams of water, and we want to find grams of hydrogen from it. What are we going to do? Grams of hydrogen on the top and grams of water on the bottom. So, in H2O, how many grams of hydrogen are there? 2.02. And the mass of water is 18.02. So we get 0.101. And now look at doing this. Do you see that? It's essentially doing the percent composition. You know, part over whole. We're just not putting it in the percent, we're just using it as the ratio. Now, we were also told that the total mass of fructose is 1.50 grams. So if we subtract the grams of carbon and the grams of hydrogen from it, we're going to get the grams of oxygen. And so now look what we have. We have 0.600 grams of carbon 0.101 grams of hydrogen, 0.799 grams of oxygen, percent to mass, mass to mole, divide by small, multiply till whole. This step's already done, and now it's just like a regular empirical formula problem. Okay, divide by the smallest. Top and the bottom one are 1. The middle one is 2, because that's really about 0.05. And so we have CH2O as the empirical formula.